The construction sector produces a large portion of emissions, amounting at roughly 40% of the global energy demand and related carbon emissions. The material intensity of the current mainstream market is unsustainable. The pressure of the rapid urbanization phenomenon on one hand and of meeting the climate targets on the other one is a concerning challenge that clashes with the inertia of the sector. Non-conventional materials are recognized to reduce carbon emissions and build healthier environments. Many of them have their roots in traditional vernacular construction. They were locally available, either by being widely found in nature or, in the case of bio-based materials, as byproducts of self-reliance agriculture. However, today their use has diminished drastically in favor of highly processed industrial materials. Therefore, designing and building with non-conventional materials has become challenging due to the lack of support by big industries promoting their scientific understanding, assessment methods, and insertion in building codes. These considerations are the drivers of this study, which is based, for the most part, on empirical research. Real-scale field prototypes will serve as the main bed test. The principal building techniques studied are load-bearing strawbale, lightearth and timber, and hemplime construction. The focus is on understanding the material's properties and on the detailed design of the related building techniques to maximize their performance and durability. Field on-spot and continuous monitoring is to be coupled with laboratory samples and prototypes testing for the characterization of materials when needed. Environmental impact assessments are to be performed in compliance with EU standards and by benefiting of primary sources to the greatest extent. In addition, impact assessments will also include case studies to broaden the palette of results. These are ecologically oriented buildings chosen for the efforts made for a low impact on the environment. The final scope is to incorporate data on the performance and on the environmental impact of non-conventional materials with a holistic vision on the strategy for a paradigm shift towards the evolution of their use in construction to help meeting the targets of energy demand and carbon emissions reduction, an approach leading to building today the inclusive, safe, resilient and sustainable human settlements of tomorrow.